Right, in lesson 5.3, we are going to recognize and apply properties of inequalities to the measures of angles of a triangle. We're also going to recognize and apply properties of inequalities to the relationships between angles and sides. So for any real number a and b, a has to be greater than b if and only if there is a positive number c. So if I were to add two numbers, basically, this is just explaining an inequality. It has to be greater than. So when it comes to triangles, we have to have two sides kind of that we're comparing, or two angles. So for example, in this exterior angles inequality, A and B, we know the sum is equal to 1. So that means that 1 is going to be greater than A, and 1 is also going to be greater than B, because the two of them add up to 1. So 1 must be greater. So we're kind of looking at the exterior angles. So if we look at, I'm going to just circle them, 2, 10, and 16. 16 is the exterior, so we know it has to be the largest. So then is it 2 or 10 that's the smallest? I'm going to box that in and I'm going to circle the largest, which I already circled. Well, just looking at them, 2 has to be the smaller, so I'm going to put a box around 2. And now we're going to compare 14, 11, and 4. So here's 14, here's 11, and here's 4. So the two of these add up to 14. So the exterior is going to be the bigger one. So we're going to circle the 14 because it's going to be the biggest or the largest. And then I'm looking and comparing 4 and 11, which I know we don't have numbers, and I always tell you, make sure that you know number-wise. Don't just judge it by its picture. But in this case, in order to kind of find the smallest, we just need to look and do kind of judge it by its size here. So 4 is smaller than 11. So if you want to try some of these, go ahead. If you want to just continue to follow along, we're going to take a look next at 1, 8, and 10. So if we kind of think of the exterior is going to be this one, 10, because 1 and 8 would add up. The ones next to each other add up to 10. So that means 10 is the largest. And then it's really hard to tell on here which one is the smallest. I'm going to go ahead and just say 1. It's more of just a guess kind of on that one because they look pretty similar. 11, 5, and 17. So 11 and 5 add up to 17 because 17 is in the exterior. So I'm going to circle 17 since it's the largest. And then I can tell 5 is smaller. So go ahead and try that last one and check when you're ready. And hopefully you circled 15 is the largest and 12 would be the smallest. So the side relationships, the longest side is across from the largest angle, and the shortest side is across from the shortest or smallest angle. And so vice versa, angles, the biggest angles opposite the biggest side. So let's take a look at this triangle ABC here. We want to go from smallest to largest angles. Well, they're giving you sides, which means we start with the smallest side, and across from that is going to be the smallest angle. So angle C. Then we find the next, which would be that one. So it's across from A is next. And then the largest side is across from the largest angle. So angle B would be the next one and the last one in order. So now let's go and talk about sides. If we start with the smallest angle, we'll find the shortest side. So here's our smallest, go across, and that would be AC. So AC is the smallest. Next is going to be AB. And then lastly, our 80 here is going to be BC. All right, so Ebony is following directions for folding a handkerchief to make a bandana for her hair. After she folds the handkerchief in half, the directions tell her to tie the two smaller angles of the triangle under her hair. If she folds the handkerchief with the dimensions shown, which two ends would she tie? Well, the smaller angles are going to be across from these sides here. So that would be angle Y and angle Z. ACT question, you can try that one on your own here. And that is it for lesson 5.3.